Hello everybody and welcome back to another Algebra 1 video. Today we will be continuing Chapter 5 with Lesson 5.3 on linear function patterns. First, I'll go over the definition of a linear function. So a linear function is a function whose graph is a non-vertical line, and it can be written in the form y equals mx plus b. You might recognize this form to be slope-intercept form, which we use a lot to graph linear functions. And if you recall, the m represents your slope and b will be your y-intercept. And when we say that it is a function whose graph is a non-vertical line, what we mean by a non-vertical line is that the line has a slope. So for example, if you see these two lines that are graphed on the coordinate plane, you see that they have a slope, that they are non-vertical lines. Here's just a brief refresher on what functions are, and we did learn this in our previous lesson. So a function is a relationship that pairs each input with exactly one output. So in the case of linear functions, your input would be your x value right here, and that would be paired with one output, which would be your y value. The domain is going to be the set of all possible input values, basically all the x values that you plug into your function, and then the range is going to be the set of all the output values, so basically just all the y values that you have. Let's get started with this first example. We're going to use the graph to write a linear function that relates y to x. Looking at the 4 points that we plotted on our graph, we can see that they form a line, and that's because they represent a linear function. So when they ask us to write a linear function that relates y to x, that just means that they want us to write an equation for the line in y equals mx plus b form. To do that, you're going to need to know two values, m, which is your slope, and b, which is your y-intercept. Remember that slope represents rise over run, or the change in y over the change in x. So as long as you have 2 points on the line, you can go ahead and plug it into y2 minus y1 over x2 minus x1, which represents the change in y over the change in x, and you can get the slope of the line. So just choose any of the 2 points that lie on your line. In this case, I chose 4, 3, and 2, 0, but you can choose any 2 of these 4 points. And then you're going to label them either ordered pair 1 or ordered pair 2. I'll go ahead and make 2, 0 my first ordered pair, so this will be x1, y1, and then I'll make 4, 3 my second ordered pair, so this would be x2, y2. And now that you know which values to plug in to this formula right here, let's go ahead and do that. You would get 3 minus 0 over 4 minus 2, and that would equal to 3 over 2. And there's your slope. Alternatively, if you do have access to the graph, as we do here, you can just count between 2 solid points the rise over the run. So in this case, we are rising 3 units up and going 2 units right. So expressing it in rise over run, that would equal to 3 over 2. And you see we get the same exact slope using both methods, so just choose whichever one you prefer. Now that we've found our slope, we can move on to finding our y-intercept. And finding the y-intercept is actually pretty simple. Simply just look at your graph and see which point lies on the y-axis, because this is where your line is going to cross the y-axis. In this case, the point lies at 0, -3, so we know that our y-intercept b is -3. Now that we've found both values that we need, let's go ahead and put it into our y equals mx plus b equation. Again, our slope is 3 over 2, and our y-intercept is -3, so the final linear function is going to be y equals 3 over 2x minus 3. Another example for us to try. Again, we're going to use the graph to write a linear function that relates y to x. Looking at the 4 points that we have graphed on our plane, we see that they do form a line, and again, that's because they represent a linear function. To write a linear function that relates y to x, we're just going to write the equation of the line in y equals mx plus b form. Before we start, let's go ahead and first label the ordered pairs for each of the points. This point right here is -4, 1. This point is -2, 0. Next we have 0, -1. And lastly 2, -2. So to write this linear function, we need to know two values, our slope and also our y-intercept. Again, our slope represents the change in y over the change in x. So just take any 2 points that lie on your line. I went ahead and chose -2, 0 and 0, -1, but you can choose any 2 points you'd like. And you can find the change in y over the change in x by plugging them into y2 minus y1 over x2 minus x1. You can go ahead and label which ordered pair is ordered pair 1 and which ordered pair is ordered pair 2. So in this case, I'm going to make -2, 0 my first ordered pair, so this would be x1, y1, and I'll make 0, -1 my second ordered pair, so this would be x2, y2. Now you can go ahead and just plug it into your formula. When you plug in -1 minus 0 over 0 minus -2, -1 minus 0 just gives you -1, and then 0 minus -2, whenever you subtract a negative value, that just turns into addition sign, so you're left with -1 over 2. And there is your slope. Alternatively, you can go ahead and just count the rise over run between two solid points on your graph. So for example, if I were to count from -4, 1 to -2, 0, in this case we are not rising, we're actually going down 1 unit. So we know that our slope is going to be negative. And we went down 1 unit, but we went running 2 units to the right. So we know our slope is going to be -1 over 2. Now that you've found your slope, go ahead and find your y-intercept. Again, the y-intercept is just where the line crosses the y-axis, and that's going to be represented by the point that falls on the y-axis. In this case, we see the point is at 0, -1, and our y-intercept happens to be -1. Here is a similar example for us to try. We're going to use the graph to write a linear function that relates y to x. Looking at the 4 points that are plotted on our coordinate plane, we see that they do lie on a line since they represent a linear function. So first thing I want to do is I'm going to label the ordered pairs for the points. So this first point would be -4, 1. This would be -2, 0. We also have 0, -1, and 2, -2. Now that we've labeled them, we can go ahead and write a linear function that relates y to x. Remember, this just means that we're trying to write a linear equation for our line in y equals mx plus b form. To do this, we're going to need to know the slope and the y-intercept. First, I'm going to find slope. Remember that slope is the change in y over the change in x. To find slope, you can take 2 of the points that lie on your line, any 2 points that you'd like, and then you can find the change in y over the change in x between those 2 points. I went ahead and decided to choose -2, 0 and 0, -1. And to find slope, you can actually take your ordered pairs and subtract y2 minus y1 over x2 minus x1 to find your change in y over your change in x. So to plug in the correct values, you want to label one of your ordered pairs 1 and the other ordered pair should be ordered pair number 2. So I'll go ahead and make negative 2, 0, x1, y1. This would be my first ordered pair. And then 0, negative 1 can be x2, y2. And that would be your second ordered pair. So you can go ahead and plug it into this formula right here. So I would have negative 1 minus 0 over 0 minus negative 2. 0 minus negative 2 would just make 0 plus 2, and you would get negative 1 over 2. Now alternatively, since you do have your graph, you can actually just count the rise over the run between two solid points on your graph. So for example, if I were to count the rise over run from negative 4, 1 to negative 2, 0, in this case, rather than rising, we're going down 1 unit, which means our slope will be negative. And after you go down 1 unit, you're going right 2 units. And then from negative 2, 0 to 0, negative 1, you're also going down 1 unit and 2 units to the right, which gives you the slope of negative 1/2. Whichever method you prefer, you can go ahead and do that. And once you've found your slope, all you have to do is find your y-intercept. Now, remember that your y-intercept is where the line crosses the y-axis, so you're trying to look for the point that lies on your y-axis. In this case, it would be 0, negative 1, so your y-intercept is at negative 1. Now that you have both your slope and your y-intercept, remember we're writing our linear function in the form y equals mx plus b. So just plug in negative 1/2 for your slope and plug in negative 1 for your y-intercept. And that would give you the final linear function of y equals negative 1/2 x minus 1. In this example, our ordered pairs are actually given in a table rather than being graphed on a coordinate plane, and you can actually find both your slope and y-intercept just by looking at the ordered pairs that you're given in a table. But I'll go ahead and graph it just in case any of you want to be able to visualize it on a graph. Remember that for linear functions, you only need to graph a minimum of 2 points in order to draw your line. I'll go ahead and graph these 3. Negative 2, 7 would be right here. Negative 1, 5 would be right here. And 0, 3 would be here. Now 0, 3 happens to be our y-intercept. And just a tip for those of you who just want to use the table that you're given, your y-intercept is always going to be where your x value is 0. And that's because when your x value is 0, that's when your point is going to lie on the y-axis. And in this case, your y-intercept would be positive 3, as you see here on your graph. You can go ahead and connect your dots with your line, and now we can find the slope. Remember, slope is the change in y over the change in x, so you can just take any 2 points that you are given in the table. I went ahead and chose negative 1, 5 and 0, 3, but again, you can. Now that you have your 2 ordered pairs, you can go ahead and use y2 minus y1 over x2 minus x1 to find your slope. Now you want to first label one of your ordered pairs ordered pair 1 and the other ordered pair 2. I just wanted to note that it doesn't matter which one you label ordered pair 1 or 2, just as long as you're putting it into your formula correctly. So I went ahead and labeled negative 1, 5 ordered pair 1, so this would be x1, y1, and I made 0, 3 my second ordered pair, so this would be x2, y2. Now go ahead and plug it in. You would have 3 minus 5 over 0 minus negative 1. This 0 minus negative 1 would turn to 0 plus 1. 3 minus 5 would give you negative 2 over 0 plus 1, which is 1. So your slope would just be negative 2. Alternatively, we do have our graph here, so you can go ahead and find 2 solid points on your graph and find the rise over run. Now in this case, if I start from negative 2, 7, instead of rising, I'm going down 2 units, so we know that our slope is negative, and then I'm going right 1 unit. So in this case, our slope would be -2/1, just as we got here. And if you were to go from -1.5 to 0.3, you're also going down 2 units over 1. And if you're a little bit confused as to what is positive slope and what is negative slope, I do have a video that covers everything about slope. Just a quick refresher is that negative slope will always go up to the left, as this line does, and positive slope always goes up to the right. So now that you've found your slope, we can go ahead and find your y-intercept, which we actually did earlier. So we know that our y-intercept is where our line crosses the y-axis. So we're looking for the point that lies directly on our y-axis. In this case, that's at +3. So now we know for y equals mx plus b, we can replace m with -2, and our b value is going to be +3. So our final linear equation would be y equals -2x plus 3. Here is another example where ordered pairs are given in a table rather than plotted on a graph. I'll go ahead and graph it on the coordinate plane just so you can visualize it. So what I notice here is that all my ordered pairs actually have a y-coordinate of 2. And I'll go ahead and graph it just so you can see what this would look like as a line. So we have -2, 2 right here. We have -1, 2, 0, 2, and 1, 2. And looking at our points, they do lie on a line, but they lie on a horizontal line. In this case, a horizontal line does count as a linear function since it counts as a non-vertical line. I'll go ahead and connect my points with a line, and now I can find my slope. Now if you recall from my slopes video, a horizontal line will always have a slope of 0, but if you don't remember that, we can go ahead and use y2 minus y1 to find our slope. You can choose any 2 points from your line. I went ahead and chose 0, 2, and 1, 2. And we're going to find the change in y over the change in x using y2 minus y1 over x2 minus x1. I'll go ahead and make 0, 2 my first ordered pair, so this would be x1, y1, and 1, 2 will be my second ordered pair, so this would be x2, y2. And now you can plug it into this formula right here. You would get 2 minus 2 equals 0 over 1 minus 0, which is 1. 0 divided by 1 would just be 0, so your slope in this case would be 0. And now you can find your y-intercept. Looking at our graph here, our line crosses the y-axis at 2, so we know that our y-intercept is going to be 2. And when you're trying to make it into a linear function, remember that it's y equals mx plus b. Since your slope is 0, you won't need the mx in your equation at all, and you can just put y equals to your y-intercept. So the final linear function is y equals 2. Now if you recall from chapter 2, horizontal lines always had the equation of y equals to a y-intercept. So in this case, y equals to 2. Here is a real-life application problem. We're going to graph the data in the table. For part A, you're going to determine if the domain is discrete or continuous. Remember, domain represents all the x values that you have. So in this case, you're going to be looking at your hours kayaking. Part B is to write a linear function that relates y to x, and that's what we've been doing in the last few problems. Then lastly, you're going to determine how many calories you burn in 4.5 hours. First, let's determine if the domain is discrete or continuous. A tip for determining domains is you have to think to yourself if you can have a fraction or decimal amount of the domain, which are your x values. So for example, if your x values are time, like seconds, you can have 1.34 seconds or 1.5 seconds. So in that case, your domain would be continuous. But if your domain is something like movie tickets, you can't have 1.34 tickets to a movie, only values like 1 ticket, 2 tickets, 3 tickets. So that would make your domain discrete. And if you need a reviewer on domains, go ahead and check out my other video on the domain and range of a function. So in this case, our domain or x values are hours kayaking. Thinking to ourselves, can we have fraction or decimal amounts? We can, since you can have values like 2.5 hours or 2 3/4 hours. So in this case, our domain would be continuous, since time can represent any value greater than or equal to 0. Now that we've determined domain, we can go ahead and write a linear function that relates y to x, which just means we're writing an equation for the line in y equals mx plus b form. First, I want to graph our ordered pairs. In this case, they're given in a table right here. First, we have 2 600, then 4 1200, 6 1800, and then 8 2400. Now that we've graphed all our ordered pairs, we can go ahead and find slope. So just find 2 ordered pairs that lie on your line. I went ahead and chose 2 600 and 4 1200, and go ahead and plug them into y2 minus y1 over x2 minus x1. I went ahead and made 2 600 my first ordered pair, so this would be x1 y1, and 4 1200 can be my second ordered pair, which is x2 y2. Again, it doesn't matter which ordered pair you label 1 or 2, just as long as you're plugging them in correctly into y2 minus y1 over x2 minus x1. If I plug in my values, I get 600 over 2, and that would just give me a slope of 300. Now that we know our slope, we can go ahead and find our y-intercept. In this case, we're actually not given our y-intercept in our ordered pairs, so we're going to have to use slope, and the ordered pairs were already given, to find it. So I'm going to use my slope to count down from 2 600 until I hit the y-axis. So if I'm trying to find a point below using slope, we know that our slope is positive 300. So I'll go down 300 units, and then 1 unit to the left, and then down another 300 units, and 1 unit to the left until I hit the y-axis. In this case, I hit the y-axis at 0. So I know that my y-intercept, or b, equals to 0. And if you're wondering how I counted down 300 units, 2 units is already 600, so 1 unit must mean 300. Now that you've found your y-intercept, you can go ahead and connect your points with a line since your domain is continuous. And now you can write your linear function since you have both your slope and y-intercept. You can replace m with your slope of 300, and you can also replace b with 0 if you'd like, but you really don't have to. So your final linear function would be y equals 300x. Now for the last part of this problem, we want to know how many calories we burn in 4.5 hours. So if we want to know how many calories we burn, we're trying to find our y value, and we already know our x value, which is 4.5 hours. So the way we find this is we're just going to take the linear function that we wrote, which was y equals to 300x, and again we're trying to find our y value, so just plug in 4.5 for your x value. So that would be 300 times 4.5 equals to 1,350 calories. So that means that in 4.5 hours, you will burn 1,350 calories. That is it for today's video. Thank you so much for watching. If you have any questions about the problems that I teach in these lessons, Please feel free to contact me at kaylin.david24@gmail.com. As always, all information regarding tutoring, lesson requests, and additional practice will be linked down below. Again, thank you so much for watching. Please like and subscribe if you enjoyed the content, and I hope to see you in the next video.